What would happen if the sun began to fall upwards or downwards or sidewards? In which direction should it actually fall towards? The first layer of this question we have to answer, I think, is children. They are basically satellites to their parent. If this is the parent, then the child is basically a satellite that revolves around the parent. Of course, this was just a joke. Now, if we take a look at the Earth, we are basically only bonded to the Earth because of the Earth's gravity. So therefore the question is, what happens to us if the Earth just dissolves? This is layer 1. And I actually can't really answer this question because my knowledge of physics is far too limited to answer this question correctly. But given the fact that the sun is actually just a point in space, and the space is basically infinite, almost. I mean, we have the sun. So maybe we could potentially fall towards the sun, but in which way would we potentially fall towards the sun? So, if we are on our trajectory, this is the sun, this is us. We rotate around the sun. Depending on which direction you see this is actually counterclockwise or clockwise, if you look from here or from here. So now, what happens is that this essentially is a system. And this system is very easily explained with you holding a bucket of water and having a string attached to the bucket of water. If you then swing this thing around and you spin and you spin and you spin and you spin, this bucket of water actually stabilizes in a disc, basically not a disc, but a circular motion around you. And the water actually stays in. Why does the water stay in? Because there is a force that holds the bucket of water. So you again here, and the satellite of being the bucket of water out here, that keeps the water bucket from just floating away into space. Of course, on the Earth, it wouldn't necessarily float away into space. On the Earth, actually, if we want to establish a system like this, we have to begin like this. So if this is you, then you begin like this, you begin swinging, and as you swing, it becomes higher and higher, and then actually it's now in 2D, essentially. But before, it is actually not in 2D, because we first have to basically overcome the Earth's gravity in order to then establish this. So we basically have two forces. The first force is the force that pulls the bucket of water down initially, and the second one, that is then the centripetal force that takes the bucket of water and attaches it basically permanently as long as it rotates. So basically given a certain motion that comes from you swinging the water bucket around you, keeps it in this perpetual motion. So now the question is, what happens if the string tears or disrupts, tears, rupts? Because, no, not because. If the string ruptures, then what happens is that the satellite that is revolving in perpetual motion is just going into empty space. It's just driving off. Of course, on the Earth, this wouldn't really be the case because of a lot of different variables, such as the air, for example, being something that slows down. But also, if you throw something if you throw something into the air on the Earth, then it actually goes down again. But it doesn't go down if the velocity of this thing, not the velocity, but if you throw this thing high enough, what actually happens is that it begins to spin around the Earth, in theory at least. Of course, then only if the system is actually in balance. So therefore, it only spins around the Earth if these two forces we just discussed are equal. The first force being the force that draws the thing towards the Earth, and the second being the force that drives the thing outwards. So basically on a tangential line, it would drive the thing outwards at any point in time. If you stopped, so this is the thing again, and now this is basically the distance in between those two. And if the thing rotates in perpetual motion here, and here it ruptures, then this thing would go on a tangential line into space. Of course, again, not really on the Earth. But now, if we want to solve the riddle of what would happen to us if the Earth actually dissolved, then we would just float in space, first of all. But we are already kind of floating in space. We are just attached to the Earth. So basically, we are actually floating all the time. It is just that the gravitational force attaches us. We are actually not connected. We can actually jump, and then we are not connected on the Earth. And if you, again, jump high enough, you might become an Earth satellite. So, not to establish any new fitness goals here, but the thing I find so fascinating is that if we then take the sun, and the question obviously is, would we fall towards the sun? Or would the sun just take over as the bigger gravitational system around which we then as humans would spin around? Of course, there is also the bigger question of the atmosphere and so on. Let's just assume we would just be rocks. We would just be rocks with a density of ours, and therefore there would be no need for us to breathe or something like this. The question, I think, is what would happen to us? And I cannot fully answer the question. I can only guess. And of course, we not only assume the Earth dissolves, but also the other planets, just for simplicity's sake. So now we have a lot of things that are in our solar system and that potentially are just there. They just are in space, whereas the sun is in the center. So now the question is there something similar that has already happened? And the answer is, I think, yes. And the similar thing is the asteroid belt. The question now is, are we of high enough mass that actually the sun impacts us and we impact the sun in a bidirectional way? But since the gravity of the sun is so much bigger, then oh man, my mind just came up with a very bad joke. If the sun is just so much bigger and it also has so much more gravitational force, it probably is the bigger system that creates a bigger gravitational force on us. So the question obviously is then, would we just be an asteroid? Would our situation then be similar to an asteroid? I guess yes. So let's just assume this to be the case. So now the sun dissolves. And also a very interesting question is, why is the sun in here? Why isn't it here or here or here? Another interesting question is the question why our solar system is actually 2D actually. If you think about the solar system, you think about the sun, star, not star, planet. Why is it a 2D disk? I think that has to do something with gravity. And you might wonder, haven't I recorded a video like this exactly before and also posted it exactly before? The answer is yes. But I think because I did this video before and also the video before wasn't too bad, I think I would just post both or only this one. I don't actually know right now. So now we have already the sun. But what we also have to kind of understand is that we already are. So our trajectory in space is not only us. So because the Earth is also rotating, this is also something you cannot really forget. It's not that you cannot really forget it, it's just that you have to also keep this in mind. So we are already rotating with the Earth. The Earth is constantly rotating. And we are constantly rotating around the Earth. Then the Earth is rotating around the sun. Let's actually do it like this, because then it becomes clearer. So basically very small circles. This is basically our movement path in space, in 2D space for now. So now, if we remove the Earth, then our movement path potentially becomes like this. So it becomes simplified. With every satellite we have that is basically bigger than us, but closer to us, that forces us into a perpetual motion around this as a satellite. Basically, we are satellites to the Earth, you could say. But we also are on the Earth, so therefore, maybe the definition of a satellite is much more that is something that is spinning around in a certain distance from the initial gravitational force, or from the thing that creates the gravitational force. The next step now would be, if the sun dissolves, what would happen to us? So we are now in this motion around the sun. What happens if the sun dissolves? We would again move, and we would move into different directions depending on our current trajectory. Because we lived on Earth together this far, I guess the trajectory of humans would be maybe similar. But let's think about the solar system before again. The solar system here, the sun again, and all these planets are of course not in line. We only draw them in line whenever we represent it in visuals. So therefore, these all go off into different directions into space, but only in 2D space. Why? Because of this weird gravitational thing that forces objects that are in perpetual motion around something to be in a 2D spaceline. which I cannot explain right now, but it is the case that Mercury, for example, doesn't revolve around the sun like this, and we like this, or like this, or like this. It could be any form of eclipse. Not eclipse. Is it eclipse? I think so. Or circle. So now the sun dissolves. And if the sun dissolves, the question is there a bigger inertial system, not a bigger inertial system, but a bigger system of which we are a part of? And I think the answer is yes. The answer is that probably in the center of the Milky Way, similar to our sun and similar to the Earth, to us, there is a black hole that is basically the center. And if you ever saw the Milky Way, it is actually a thing that is a spinning disk. Again, it is a spinning disk. So we have these stripes of the Milky Way, basically similar to a flower, and these then revolve around the center of the Milky Way, and you could now assume that there is a black hole in the center of the Milky Way. And of course, the Milky Way is something many people will still realize. The bigger thing is then galaxy cluster. The Milky Way is our galaxy, but it is also a galaxy. And I think the next big galaxy cluster, or if this already is a galaxy cluster, or just a galaxy S10, is the local group. But this is, in the local group, there are only a few galaxies, actually. It basically is very similar to a boy group, you could say. It is just made up of locals. And one of these locals is the galaxy that is ours, which is the Milky Way, which I cannot really identify, but this is probably how it looks like. It seems to be a kind of cylinder, and there seem to be a few galaxies within this. But this doesn't seem to be a spinning thing. So now the question is, when does this gravitational thing end? And also, maybe is in the center of the universe, or where is actually the center of the universe, or is there actually a center of the universe? Which is also a very interesting question. A very interesting question I cannot answer right now. So somewhere it ends, I guess. But what we also have to keep in mind is the fact that everything in the galaxy is moving away from everything else in the galaxy. Think of a balloon. If you have a balloon, so this is the balloon in the beginning, and then you begin to blow the balloon up. And everything on the balloon, so we assume that there are parts on this balloon which are on the outer side. And now if you expand this balloon, everything becomes farther apart. If you, for example, take this fingernail, then in the beginning they are close to each other, but if everything moves apart, then everything becomes much more apart from each other. So therefore we are not only driving in circles around our sun, but we are also driving in circles with our sun around the Milky Way galaxy center. And then I don't know what is actually the next bigger thing. Of course, there is also the theory of the multiverses, which could potentially also maybe have a gravitational center. There are also a lot of other mysteries that are still unsolved, like dark energy and dark matter. But I think, to sum it up, the thing we often, or at least I often forget is, I am standing here, nothing basically happens. But as I am standing here, I am revolving with the Earth around its own axis. I am also revolving around the sun. So basically we are in multiple layers. We are involved in multiple motions that add each other on top of each other. And so basically, again, we are on the Earth, spinning around the Earth. The Earth is also rotating. Of course, the Earth is not really rotating on its own axis very nicely, but it's also tilted. So therefore, it's also tilted in space, which is also very weird. And we are then moving around the sun, and the sun is moving around the bigger galaxy. And we are also moving around the sun. And then everything is also expanding. Well, that's just the end.